So MACI stands for Minimal Anti-Collusion Infrastructure, and basically it allows you to run private votes, private polls on chain. The main properties of it are collusion resistance. So only the coordinator can be certain of the validity of the vote. You cannot prove behind any reasonable doubt how you voted to someone. Privacy, so only you as the voter and the coordinator can decrypt your vote. Votes are not censorable, and you cannot really edit or delete a vote, but you can nullify it. And finally, the coordinator cannot produce false output. Why do we need it? So there's a lot of quadratic funding and quadratic voting applications being built. And bribery is a very common problem because in this type of protocols, the majority of people can actually make a difference. If collusion is easy, then specifically for quadratic funding, the funds might go to projects which do not really deserve them. And at the same time, if your votes are public, you could also be conditioned. Whereas if you don't really know how anyone else voted, you also might want to do more research on the projects you're voting for. And finally, which is kind of like the main gist of MACI, is that because you cannot really prove to someone how you voted, then why would they bribe you? Okay, so technical details. The architecture, we got three main components. So we got the smart contracts. These work only on EVM compatible chains. We got circuits. These are written in Circom, and we have a quadratic voting and non-quadratic voting flavor of it. These are used to process messages and tally the votes. Finally, we got some TypeScript utilities, which you can use to play the coordinator and then process the votes, interact with the protocol, both as a user or as coordinator, and some of the primitives which you can use to build on top of it. These include MACI public keys, encryption algorithms, and hashing algorithms as well. This is what the repo looks like. So if you do decide to hack on MACI, you probably won't touch the circuits. These are in red, whereas what you'll be using the most are the ones in blue, everything that is written in TypeScript. So within the CLI, you'll find an SDK to build a front end with it or whatever you choose. So, and the core will be the clone of the smart contracts, which is used to process messages and generate inputs for the circuits. Finally, we got the smart contracts written, the one in the green, and you'll find test, deployment scripts, and everything you need there. So, as a user, the first thing you would do when you interact with MACI is you create a MACI key pair. So this is your identity in the MACI system, and that is not to be confused with a Ethereum public key. This is the serialized form. You can see it here. Basically, this is a point on an elliptic curve. Won't dive on the math part of it. But when you register, you send your public key, and this is stored on a Merkle tree on chain. When you vote, you will take the key of the coordinator and use ETHGlobal to generate a shared key. This way, you encrypt the message. So whatever you send on chain is all encrypted. But when the coordinator pulls the data off chain, they'll be able to reverse the encryption. You also sign your vote, so no one can really publish a vote for you. Finally, you might want to verify that everything was done correctly. So that would be after all of the processing is done, and you'll be able to interact with the smart contracts, submit CK proofs to just verify that the result of the poll was conducted in a correct way. This is what the coordinator does. So fast forward to the end of a voting round. The coordinator will merge the Merkle trees-like structures, pull all of the events from the smart contracts, and generate the state locally. So this is like a copy of whatever happened on chain. And from there, they run this TypeScript code to process the messages. So you decrypt the message, you verify that the message is valid, and then we go and generate snark proofs. These proofs are submitted on chain to one of these smart contracts, and there's some commitments to this data. The same is done as well for the vote tallying. We assume that the coordinator is honest, but it's also true that what they could do is they could actually collude with bribers themselves. Currently, as the protocol stands, there are some work in the pipeline to improve on that, but technically they could decrypt the votes and just publish them, or they could just decide to not conclude the vote. But some of the good stuff is they cannot really censor any of the votes, and that is thanks to the smart contracts, and they cannot perform any incorrect processing thanks to the ZK SNARK circuits. Everything that is to consider the source of truth will be on chain. So we will have the root of a tree holding the signups, the root of the tree holding the messages, the number of users that signed up, the number of messages. So whenever a user or the coordinator tries to verify the proofs, this data will be pulled from the smart contracts. And let's say the coordinator is trying to say, I process all the messages, but he only sends data for 99 messages when there were 100, the proofs will not validate, and user will know that. Right, so for the hackathon, some of the stuff you guys could build if you wish to. Like quadratic funding applications, there's a few of these. You can take inspiration from them if you want, like Fun, for instance. DAO voting apps or toolings for DAO voting. Some Sybil resistance mechanisms for MACI, so like gatekeepers contracts. There's some cool ideas like using this proof of personhood, like proof of passport or not. So like only users that using ZK proof they're human can join a MACI poll, or even like build some front ends for them, like one to manage or one just to contribute. We have a discussion here on GitHub. I'll share this later on so you can just click on it. And all of these projects are there and a few more as well. In terms of how you can build on it, we're going to be looking at the smart contracts here. So we got the user and the coordinator, right? So the coordinator deploys the MACI smart contracts alongside this gatekeeper and a voice query proxy. You as a user, or anyone as a user, signs up with their key, and the smart contract will make these calls, and this simply answers, can I sign up? So do I pass certain criteria, which you decide? Or, and this one, how many votes credits do I get? So like, what is my voting power in this poll? This can be like a constant value, everyone gets the same. Some people get more because, let's say in a quadratic funding protocol, they contributed money to the matching pool. It's just up to you to decide as the builder. Then the coordinator can deploy polls. Calling this function will basically trigger 3 deployments: a poll contract, a message processor, and a tally. The poll one is where the votes are sent. So you as the user will just call directly this contract and send your votes. The message processor is for coordinators to submit proofs of correct message processing, and so is the tally. But on top of that, in the tally, you can actually call some functions from the user perspective to verify that everything was done properly. So just one example here is a very simple quadratic funding protocol I tried to build using MACI. This is like the main contract which inherits from MACI. So within the constructor, we pass all the parameters the MACI needs, plus a few more that we need. So because this is a quadratic funding, we need a token so user can contribute to, and a recipient registry is just a list holding the addresses of the projects that are part of this round. Here, something that you might do as well if you build and you change the contracts, is overriding the sign up function. So as you see here, we call in the normal MACI one, but on top of that, we are taking some funds from the user and storing how much they contributed there. Again, like if you change any of these free concepts that I showed here, you can extend the deploy poll function to do the deployment plus extra. So I extended the tally contract to have an initialize function. So here I can just call it as well. And here is like the tally one. So what's interesting here is as a user, or well, as a project part of a round, if you want to, when it's time to claim the funds, so when all of the messages have been processed and the ballots have been tallied, so the results are there publicly available, anyone can trigger this function, send the snark proof, the vote option index. So imagine an array of projects. Let's say we want to send the funds to the first project. This will verify that the TK snark proof is correct. And however many funds or votes they will be receiving. And yeah, in terms of bounties, we got 5 bounties, but I thought the medals look cool. So you got 1, 2, 3, 2,500 for the first, then 1,500, 1,000, 4 and 5th was split 1,000, 50-50, so 500 each. And if you do decide to build, feel free to come to me. We can talk ideas and whatnot. And yeah, again, to conclude, we think that privacy is very important, and especially private voting. We hope there's a future to this, and we do hope the MACI can help make a difference. There's a lot of work that needs to be done, and it's nice to come to hackathons and get your support, or even if after this you guys are happy to just give some open source contributions. We're always open to hearing your ideas and helping you collaborate. If you want to reach out, there's Discord invite for the PSC channel. And yeah, like if you got any questions, now's the time. Yeah. Oh, well, I'm done. Yeah, I mean, if you have questions, really, yeah. Sweet.
Yeah, thank you for the talk. I just have a question regarding the...
Sorry. Could you say that again?
Yeah, I just have a question. You generate a share secret between a user and also the contract?
It's cool.
Yeah, so the client will generate a public and private key for that. But I was curious about the private key that would be used for the share secret. Which one owns it? Is it the deployer of the contract? Or
Okay. Right. So you have your own private and public. So that's the coordinator. So the coordinator will publish their public key. Okay. You, when it's time to encrypt your vote, you generate a random key at that time. Okay. So for each vote, you can generate a random key. You take the private key and the coordinator public key. You use the CDH to generate the share key. You encrypt with the share key, and then you send alongside the message this random public key. So the coordinator takes the message, takes the random public key, their own private key, and they get the same encryption key. Does that make sense? Yeah? Sweet. Anyone else? Of course, yeah.
so in this case, we need to be sure that the deployer will be trusted, because it will manage all the private encryption during the system.
Correct, yeah. So we assume that the... Oh, okay.
Yeah, and to continue with that, we just assume that the one that going to deploy the smart contract that's going to generate a share secret, it is trusted in the process, right?
Yes. So I mean, technically, the deployer doesn't need to be this trusted party because they only need the public key, right? So anyone could deploy and then send this coordinator public key. But yeah, there's some level of trust on this coordinator to do everything because they can encrypt the vote and can just share them with bribers, for instance. There's some work being done on preventing this, but it's not there in production yet. But yeah, for now, that's the case, yeah. Good question, though. Thank you. Hi.
Hello. Yeah. In one moment of the process, we register the all participants. I mean, when in the start, I mean, in one moment you have 20 address, they're going to vote. You need to, it's a process, it's a moment when you need to register that. That's correct?
You as a voter, you mean?
Yes. I have at least 20 voters in one moment before I can generate the proof. I assuming it's a moment.
You can register anytime within the poll duration. So let's say the poll ends tomorrow midnight. You can register anytime before that, and your votes for that poll will count because you signed up in the correct, just before the deadline, basically.
Hi, I wanted to ask you, I was reading that there are some technical limitations to bigger amounts of voters. Could you please explain a little bit about that? If there are, and what are these limitations?
Could you expand on that? Like what type of issues?
So I was reading that there's limitations for bigger amount of voters. That's what I was reading on, I think, one of the repos or one of the articles which was explaining it.
Okay. Yeah, so basically the amount of voters is based on the capacity of the Merkle tree. So as the Merkle tree goes larger in depth, you can accept more voters at the cost of like proving time. So generating a proof will be a bit longer for the coordinator because the circuit will have much more constraints. So yeah, but technically, so we run a trusted setup ceremony for the current version of the circuits, and yeah, the one that we have in production after the ceremony is only maybe 15,000 signups. But for instance, we could run another ceremony with increasing this parameter to support 1 million. The only cost there would just be the proving time, basically.
Any more questions? Okay, so thank you guys for showing up. Thank you, Control C.
Thank you.
And
Thanks, guys.
that's it.